Our next speaker comes from Optimus 3D. Optimus 3D uses applied experience on aeronautics for additive manufactured parts. He is a mechanical engineer with experience in renewable energy, aeronautics, and additive manufacturing sectors. Ladies and gentlemen, please welcome Pablo Capellan.
So, good morning. We've heard a lot about all the other speakers going into their own special applications, but now I'm going to talk a bit more into a broader spectrum from what our own experience. So, we are a service provider that we are providing service for additive manufacturing for all different sectors, all the way from medical to the aeronautics. I'm focusing the presentation on aeronautics, but basically we apply these values to all our customers. So you can see that we are having we are always getting personally involved, and we are having solutions that are tailored to every customer. We are also having different machineries from SLM to that would be for metals and also for plastic and resins, and we are trying to focus a lot on quality. So our main services would be product design, engineering, testing facilities, and then we also have scanning, manufacturing, and measuring. Going more now in detail into what it is that we are selling to our customers is that, we treat any request as unique. In our request, what we get is we review the whole application, and then we try to see what we can do to that application. So normally the customer comes with one idea and say, we want to do this with this kind of technology, with this kind of material, and we are trying to get away from that and say, okay, let us read through, tell us all the loads that you are going to apply to your part, and then we will try to decide if the process that you are trying to use is the correct one, or if you are trying to, or we should try another alternative. Then we have all those alternative spectrum and see the feasibility and try to see if the customer agrees on that, and then if the numbers match, then we go for the production. What you can see on the picture is three different alternatives for the same part, where we try to find the most cost-effective and less time-consuming approach for one SLM manufactured component. Now, going more into more specific parts that we have collaborated with, you can see an example of the end fittings for the antennas of a satellite. And you can see here the weight reduction for these components was 64%. The cost reduction was also less than half. And then specifically what you're seeing there is the engineering behind it is the most important part. So the approach was to redesign the fittings by applying topological optimization and generative design, and by that you consider the design to be manufactured by additive. And basically that way we achieve an overall cost reduction on these specific components. Then we have other alternatives or other applications where we applied additive manufacturing for the aeronautics industry, and that would be for forming of composites. You can see here the standard component was made by steel, by machining, and in this way we just replaced it by plastics. So in this way we are not only getting a faster time for the customer, but we are also getting a different alternative which it's also more cost effective and provides the same solution. Then we have other operations where we try to find an alternative for a hinge where the original part was machined having a lot of material, but try to simplify those machining to reduce the amount of hours used on that. So this was made in titanium, and of course that's a lot of value for the part that you are trying to rip away and get all the chips out. So if you convert that into additive manufacturing again with generative design, you are getting the most benefit of additive manufacturing. So, last but not least, on the success cases that I want to share is one that we are just now working in progress. This is a more broad approach where we are cooperating with one big player on aeronautics into just try to redevelop and rethink the approach that you would make for the whole supply chain. So basically, before in any other kind of supply chain, what you have first is the concept definition. Then you would define which technology would be used for conventional manufacturing, and then you go into the design. Once the design is finished, then you go for validation, make the final drawings, go for the casting, machining, etc., etc. And that takes a lot of time. And people normally think for additive manufacturing into just replacing the casting and the machining, or not replacing, but just speeding up those processes. And as some of our colleagues have already mentioned, the approach of additive manufacturing allows you to go back even further and change not only those two, but make you more agile in the product spectrum from the design point. So once you have designed your component and you decide that you go for the testing campaign, you can easily see if you are going in the right direction or you need to make any modification. If you need to make any modification, you are going to be more agile if you are having the freedom for additive manufacturing, and that will also speed up the validation, the final drawings, and so on and so on. And then, yeah, where we are planning to apply this is, as I said, with a big player in the aeronautics industry. And we are trying to shift 2,000 references into additive manufacturing within 2 years. So that would be not only for plastics, but also metals. And then going a bit more into what value would Optimus 3D add compared to other service providers. So as you have heard from other exhibitors today, the most important part is the design. So if you are designing right for if you are making the design for additive manufacturing, then you are going to get the most benefit of it, and then you are going to save the cost and save the time. And yeah, you can see on the left a bracket for a motorbike that we have on the stand over here. So if you are curious, you can go and see it. And then on the right is just how the iteration for generative design works for a specific application. Then we are also trying to tailor the parameters to each and every customer. So we can see that we have several parameters that we can change, from the border and hatch parameters and so on, and that those will give each customer the quality and the cost that they will need. So starting from the very beginning, the border and hatch parameters, you can see we can apply different parameters as any other provider can, but it's just that we make the analysis to say, okay, perhaps for this part, if we go for the chessboard pattern that we see on the rightmost corner, then we can reduce the internal stress to the most, and then with that way you can have a part which is not conventionally thought for additive manufacturing. It's still manufacturable with this technology. We can also change the angular offset within layers, and that will also change the way that your final build will behave. So if you try that will basically define your grain growth once you finish your part. So depending on your grain growth for that component, that will allow you for bigger loads admission. Then we can also change the laser power output. So we have several customers which are not for the aeronautics, where they say, okay, perhaps what we are aiming for is having a lower cost for this part, but it's not very mechanical intensive, so why don't you just find another alternative where we can make additive manufacturing work? So we can either change the laser power output or even change the advanced speed to have faster production times. With the laser advance time, of course, we would inquire some defects, so to say, in porosity, but as I said, if the customer is not really focused into having this kind of mechanical intensive components, it is something that sometimes can be used. Sometimes you are going for a specific alloy that you need for some other kind of necessities, not really mechanical strength or design parameters. But then you go into so if you advance that speed of manufacturing, then you can get the lower cost with the alloy that you were aiming for at the beginning. And that would be all for